To help us understand a little bit about how we measure water content and what it all means, we're going to look today at veggie soup. So I've got 2 cans of veggie soup here. I've got can 1 and can 2, and I'm pretty sick at the moment. And so I've gone to the supermarket. I want to get some veggie soup to try and get better. And so there's two different brands. There's, as I said, can 1 and can 2. These are 2 different brands of veggie soup. Can 1 is 250 grams and will cost me $6. And can 2 is 250 grams as well, and is also going to cost me $6. And so I'm going to the supermarket. I want to get, the best value for my veggie soup. I want to get lots and lots of veggies so I can try and get better. And so, but however, these are both the same mass and the same price. So I can't really figure out which one of these is better value. Which one of these is going to have more veggies and help get me better. So what I'm going to do is I'm going to measure the water content of each soup in order to figure out which one actually has more veggies in that 250 grams. Okay, so they both weigh 250 grams when you combine the water in the soup can and the vegetables. So I'm going to measure the water content in order to figure out, if this one has more water content, then it means it has less veggies. So it's not as good value for money in terms of, the veggies that I'm going to be getting for my $6. And I want as many veggies as I can to try and get better. So we're going to measure the water content of each of the cans of soup. Now the way we're going to do this is by a process called heating to constant mass. So what we're going to do is we're going to heat these cans of soup. We're going to heat the soup to constant mass. Now, as it sounds, it's pretty much, this process, heating to constant mass, is pretty much exactly what it sounds like. What we're going to do, it's a bit of a cycle of heating. So what we're going to do is we're going to pour, say if we're heating soup can 1 to constant mass, then we're going to pour the soup, everything inside the soup can, we're going to pour it all into this beaker. We're going to put this beaker into the oven. We're going to heat it at 110 degrees Celsius. Now, so keep in mind that the idea of this heating to constant mass is to evaporate all the water, and that's how we're going to measure the water content. So we're going to heat to constant mass to evaporate all the water. So this heating to constant mass idea, so we heat at 110 degrees Celsius. So if we want to heat something to constant mass to measure the water content, we heat something to 110 degrees Celsius. Now we know that the boiling point of water is 100 degrees Celsius. So if we heat something to 110 degrees Celsius, then theoretically all the water will eventually evaporate. And so that's why we've chosen 110 degrees Celsius as this heat. So we're going to heat the soup to 110 degrees Celsius for a given period of time. That's one of the steps. So that's the middle step in this flowchart. So what we're going to do is we weigh what we've got. We weigh the sample, so we weigh the amount of soup that we've put into this beaker. Then we put the beaker into the oven and we heat the soup to 110 degrees Celsius. Then we allow it to cool. Okay, and then we go back to square one, and then we reweigh it. Okay, so this idea is that, say I start with something that weighs 10 grams, I heat it, and then I let it cool, and it comes out as 6 grams. Then I wait again, it comes out as 6 grams, and then I do it again, it might come out as 5 grams. And that means that only 4 grams of water was evaporated in the first process, and then another gram had to go in the second process. So basically, heating to constant mass is repeating this cycle, starting from here. We repeat this cycle over and over and over until two of our weight measurements are the same. 2 consecutive measurements of the weight of the soup are the same. And that means the mass is constant, so we've heated it to constant mass. And the reason we do that is, as we keep repeating this cycle, we're going to keep evaporating water. And it's not until, and once 2 consecutive weights are the same, that means we know that no water has been evaporated in the most recent cycle. So say we have 6 grams here, we do all this, and we come back and we get 6 grams again. That means no water has been evaporated in that cycle of heating. And what we take from that is that there is no water left in the sample that we're heating. So that's how we heat to constant mass. So now what we're gonna do is we're gonna heat both of these to constant mass to figure out which one has the higher water content and which one has better value for money in terms of the veggies that I'm gonna get in my soup. So first we do veggie soup one. So we start out with 250 grams. So we measure it, and the label was right. There is 250 grams of soup in veggie cam one. So 250.0 grams. Okay, we heat it, cool it, weigh it. Comes out as 29.1 grams. Do it again. Comes out as 27.5. Do another cycle. We heat it, we let it cool, and we weigh it. Comes out as 27.4. So you can see that with each cycle, the change in mass is getting smaller and smaller. That's because there's less and less water to evaporate the more times we go through this cycle. So if we do it one more time, we get 27.4 grams again. And so this is the constant mass that we're after. So we've got 27.4 twice in a row, so we know that that is the final mass. So we do it again, we do it the same thing with veggie soup 2. Again, we start off with 250.0 grams. We heat it, get down to 24.6 grams. Heat it for, another 10 minutes, say. This heating time, it doesn't need to be a strict amount of time. However, 10 minutes is probably good for this situation. We just want, a solid amount of time to really try and evaporate as much water as we can. So we got 24.6 grams, then we come down to 22.8 grams. Maybe we then go to 22.3 grams, so it's getting closer. 22.1 grams, and then 22.1 grams again. So this is our constant mass that we are after. Now, in terms of figuring out which of these soups contains more veggies and which is going to be more, a better value for money in terms of the veggies that I'm getting per dollar, we can see here already that veggie soup 1 has more veggies. It's got 27.4 grams of stuff left once all the water's gone, whereas veggie soup 2 has only 22.1 grams of water left, of veggies and stuff left now that all the water's gone. So we can already see that veggie soup 1 has more veggies in it. However, we're going to continue with the process and finish calculating the water content. Now, when we talk about water content in this context, what we mean is the water content as a percentage by mass. And what that means is just we want to figure out what percentage of the mass of this soup is water. So basically, the next step we need to do to figure out the percentage water content by mass is to figure out the mass of water in the soup. So we know that we've started with 250 grams for the veggie soup 1. We've ended up with 27.4. So the amount of water is going to be 250 minus 27.4. So that means we've got 222.6 grams of water. So we do the same thing with veggie soup 2. We go 250 minus 22.1. That equals 227.9 grams of water. So now we know how much water was initially in our veggie soups. And so the last step we have to do is figure out the percentage water content by mass. So if we go 222.6 over 250 times 100 gives a value of 89.0%. Do the same thing with veggie soup 2. Times 100 equals 91.2%. So this result has really just affirmed what we deduced from this here. Veggie soup 1 has a less percentage water content by mass. So, we're getting more of the good stuff and less water. And so veggie soup 2 has a higher water content by mass. So, more of this 250 grams of soup that I'm buying is being wasted in just normal water, and I'm getting less. Therefore, I'm getting less veggies for my $6. So what we've done in measuring the water content of these soups is we've poured out the 250 grams. We've weighed it to ensure that it was in fact 250 grams. If not, then we would have used different numbers. We wouldn't have used 250. We'd have used whatever the actual mass was in all these calculations. But both these masses started out at 250 once we poured them out. We heated it 100 to 110 degrees Celsius for a period of time. We let it cool. We weighed it. We repeated the process over and over until 2 consecutive weight measurements were the same. And then using that, we figured out the difference between the initial weight and the initial mass and the final mass when all the water had been evaporated. We figured out the difference between that, and that difference is equal to the mass of water that was initially in the veggie soup. Now that figure here. So that mass of water that was initially in the veggie soup can then be used along with the initial mass of the whole soup to figure out the percentage water content by mass of each of the soups. And so that's the standard process for measuring water content of sort of any substance that you might want to deal with.